All right, so let's do some prime factorization, a very simple strategy to help with a lot of mental math and in the future, a lot of complicated math. So prime factorization is just breaking down numbers into their prime factors. For instance, you can break down a 6 into a 2 times 3. And because 2 and 3 are both prime numbers, 6 is prime factorized. 12 has a 6 in it. So I can break down the 12 into a 6 times 2. And now I can change that 6 into a 2 times 3 times 2. And 12 is prime factorized. Okay, when you have a number like 96, of course, there's going to be a lot of prime factors, but you can just keep breaking it down by 2 and kind of collect the 2. So if I divide that by 2, I get 48 times 2, and then that's 24 times 2, and that's 12 times 2, and you just keep adding a 2 as a multiple. And that's a 6 times 2, and that's a 3 times 2. Right? You don't have to do it in this many steps, right? It just shows you that this is actually equal to 3 times 2 to the 5. So this is prime factorize and simplify. We don't want to write that many 2's. And it tells us, that I double it 5 times and then I triple it at the end. Okay, and so these factors, these prime factors, are useful when you're multiplying numbers together or when you're simplifying fractions, and we'll see that next. Okay, so let's take a look at this operation right here, 14 times 7. When you're doing mental math, a lot of guys do 10 times 7 and plus another 4 times 7, which is great. But prime factorization gives us another avenue to maybe move with a little more speed. So for instance, this 14, in my mind, I could just break it down into a 2 times 7, right? And now that this is prime factorized, I can organize the factors to kind of go towards my strengths. For instance, my strength is leaving a 2 to the end. I can double any number. So I'm going to do the 7 times 7 first. That's 49. So I've changed 14 times 7 into 2 times 49. And that's easy. That's just 2 away from 100. So 14 times 7 is 98. This is something I would do possibly in my head. When it gets a little more complicated at fractions, you would think, I don't know what 16 squared is. I don't know what 28 squared is. I surely don't know how to divide those two large numbers. But we can actually not prime factorize them, but we can factor the 16 into a 4 times 4 squared. And we can break down the 18 into a 4 times 7 squared. So this is the same as having a 4 squared times 4 squared on top, which is 16 times 16. And this is the same as having a 4 squared and 7 squared at the bottom. Well, look at this. These factors are the same. I'm going to get rid of the 2 4's over here with the 2 4's over here. And my answer to this fraction is just 16 over 49. Okay, so by using factoring, I've made the question easier instead of actually writing down what 16 squared is and then, having large numbers to deal with. Okay, lastly, let's take a look at how factorizing or prime factorizing or just factoring can help us reduce fractions. So you probably learned in like elementary school, you have to find a common factor. Well, to find a common factor, you have to visualize the factors. So for instance, 6 over 38, I can change that to a 2 times 3. I can find half of 38 and then 19 times 2. So now right away I can cancel out those 2's. Because 2 divided by 2 is 1. So I can cancel those out, and my answer is just 3 over 19. Okay, you might have thought about this as saying, well, divide both by 2. Yeah, because you know that they have a common factor that is a 2. But if you factor them, you can see it very evidently. And when questions get much more difficult and they don't have 6's and 38's, they have x squareds and a to the 5's, you kind of have to do it this way. You have to factor it to cancel out the factors. Okay, so this is my answer. Let's take a look at 24 over 99. So I'm going to change 24 into any factors. It could be a 6 times 4. It could be an 8 times 3. I'm going to change it to its prime factors. So it's going to be a 6 times 4. I'm going to change this to a 3 times 33. And I'm going to go one more step. I'm going to go 3 times 2 times 2 times 2. Now, you wouldn't have to prime factorize this like this, but take a look. Okay, so I broke down the top, 24, into a 3, that's doubled into a 6, 12 and 24. And the bottom, 99, is broken down to a 3 times 33, and then further, that 33 is a 3 and an 11. Now I'm looking at the top and the bottom, and I only have one number that becomes 1, 3 divided by 3. So this answer is 2 times 2 times 2 is 8, 3 times 11, 33. Now again, you probably could have thought of that by just dividing 3 into both. But you need to think of it this way when questions get more difficult. For instance, in the grade 11 MCR 3U math, where fractions with letters are difficult. So we're just going to actually see one reducing of fractions with letters next, and then we'll finish. Okay, so let's take a look at these expressions. You might be a little scared if you've never seen anything like this, but these are actually easier than numbers because you're kind of organizing objects instead of, counting, doing a 4 divided by 20. So over here, if I factor this entire thing, I'm going to get a 2 times 2 times x times x times x. That's factored. There's 3 x's multiplied by one another. And at the bottom, I'm going to get a 4 times 5. So that's a 2 times 2 times 5. There's an x and there's a y. Now that this is all fully factored, I can cancel out the 2's, I can cancel out the 2's, I can cancel out the x's, and my answer is x squared over 5y. Okay, again, this question is still pretty simple. The value of factoring comes more in handy when we're talking about either quadratics or, cubic functions further on in the your math career. Over here, okay, I know you probably know exponent laws, you subtract them, but the reason why you would subtract them is because you got 2 a's on top, you got 3 b's on top, you got 4 c's on top, and then at the bottom you have this. So this b takes out one of them, this takes out 2 of those, and now you have an a, the a's get gone too. I have 1 a left on top, I have a b squared left on top, and I have a, let me circle them, c squared left on top. And this is my final answer, reduced fraction. Okay, no numbers, right, needed, but by factoring and understanding prime factorization, I can get to a simplified version of an expression much, much more quickly.